So hi guys, good evening all of you. Are you audible guys? Okay, right. So yesterday we started introduction part of PLSQL and up to how to store the column values into variables we discussed guys here. And later, the next one is anchor notations, otherwise we call it as variable attributes. Okay. So what is anchor notations or what is variable attributes? Okay, so let you see guys here. So generally, variable attributes we are going to be using, otherwise anchor notations we are going to be using, okay, in place of data types. So these attributes, these variable attributes are used in place of data types. In place of data types at the time of variable, at the time of variable declaration. Okay. So I think the previously, can you identify in the previously whenever we written some program? So at that moment, what it was going to do, how many number of the variables we required for our program, the program wise, that many number of variables we declared, and we all of you know. So whenever you want to declare a variable, compulsory data type should be required. So without data type variable declaration is not possible. Okay. So the previously what we did here in the previous section. Okay, in the previous section, what we done in the previous section. So now, this is your table information. Let's start from EMP. Okay, and from this table, we need to display some name and what we can say salary of particular employee. So we declared one variable X, and the data type compulsory we should declare yes or no. So, and later Y, and this is number for salary purpose. And later we simply started begin and the self include statement we taken. So name salary into X comma Y from your EMP table, where EMP number is equal to % of EMP number. And after that we pass your DBMS underscore output dot underscore line of so X concatenate comma concatenate Y. Okay, and finally we just end here and execute it. Suppose if you enter that employee details are displayed, but your output is not displayed. So if I want to display output, what I want to use, set server output is on. Okay, now like 7788. Now, so you got it here. So that's fine here. That's fine. So, but here in this example, carefully observe. Here, X is a one variable name and type is varchar. Y is a variable name, one type is varchar. So you can take like XYZ, you can go to use it. Okay, but sometimes what happen to easily understanding purpose, that means this particular variable for which column data storing purpose we declare this variable. So that kind of user easy identification purpose. Sometimes what we are going to use instead of X comma Y. Suppose maybe if I'm using X comma Y means if any newcomer, that means any new user when they come to you. So if we are using X comma Y means this X comma Y variable are you created, are you declared for which column? So that was a little bit confusion. Yes or no? Yes or no, guys? So whatever we declared here, X comma Y, this X and Y variables, these two variables are okay for which columns purpose or which column data are you storing, so that we can't tell it. If any newcomer is there, if any new user is there, so the new user is going to be confused here because X variable we are taking for e-name column, job column, or what case we don't know. Y column is Y variable, which column purpose we declared. That is also little bit confusion. It is occurred. So that's why in real time, what they will do when they're creating variables, for storing specific column data, the column name they will take as a variable. So when they're taking like this, advantage is what now guys here. They can, anybody, not only myself, if any new user also come to us and they will see my program, they can easily understand that these variables are you declared for which columns. Okay now. So that's why in real-time applications, how the people are going to be declaring these two means. Let me see. Same one, there is no thing. Okay, same one, there is no thing. Just a different subject. Suppose I declare v means variable underscore name. So when I was declaring my variable as per column name wise, then anybody can understand two variables we are declaring for which column data storing purpose. Okay, now which column data storing purpose, they can easily understand when they want to write like v underscore e name, v underscore salary. If I'm giving, that means column name I'm taking as a variable name for easy to understanding purpose. Okay, now for easy to understanding purpose. So let you take, and after that, as usual, begin, and you can pass select e name, salary, and these two columns I'm storing into the related variables. One is v underscore e name, one is v underscore salary, emp. So where emp number is equal to ampersand the emp number. Okay. So 1 second, guys. Okay, right, guys. So now we are going to be declaring some columns, and the column values we're storing into variables. Okay, and remaining same as this. And later you have to print those variables values. So dbms underscore put underscore line of. So v underscore name is a one variable, comma. V underscore salary is one more variable. Now after that, end your operation. Let you see. So the same thing. nothing problem. But here, and you can use X and Y also, but what it was happened when I'm using X, so a little bit confusion, this variable we are declaring for which columns purpose there. So instead of that, suppose are you going to declaring now, so like this, my column, which column I'm showing here, ename. Okay, so which column I'm storing, which column data I'm storing, ename, which column data I'm storing, v salary. So by seeing of this variable declaration, then you can understand that which columns we store. Okay, so like this you can use it, no problem. But here the thing is, what is anchor notations will be, okay, what is variable attributes or else anchor notations, what it was telling us, and what is the advantage of this means option. What we said, variables attributes are used in place of data types at variable declaration. Okay, for example, when you declare like this here, so this is variable declaration. At the time of variable declaration, I'm using some data types now. At the time of variable declaration, I'm using some data types now. Okay, now? Okay, right. So now what it was going to be happen? What it was going to be happen means, so here which data type are you declared here? Based on that data type only, the values are stored. Okay. But unfortunately, for example, in your EMP table, for example, see. So in EMP table, which column purpose one ename? So ename is which data type varchar 2. So here also the variable, the ename variable is also varchar 2. So that means employee name column data type is varchar, and the related variable, whatever we declared, that variable data type is also varchar. So then both are matching, then only ename column data can be stored. So here also salary variable number, and here also salary column number. So my variable data types, my column data types are both are matching now. So whenever it was matching, then only our program will be successfully executed and that particular column value can be stored. Okay, now, so this is what the data type. But guys, here, for example, for example, suppose in the future, ename column is there. That ename column data type varchar 2. Until this column data type varchar 2, there is nothing problem to my program. There is nothing problem to my program. My program is executed perfectly and output also showing this. But suppose in my future, in future, suppose user he was changing data type of column. So suppose you need to change the data type of column. Suppose you are changing data type varchar 2, you are changing some data type. Okay, now varchar 2, some data type you are changing. So a particular column data type, how to change, that we know. That we know how to change. By using of altering command, we can change it. So when user in the future, okay, in the future, the user can change a data type of your ename column. Then what happened now, for example, I'm telling for example, now ename column data type is present, what it is here, data. But this column, okay, related variable, whatever I declared here, okay, whatever I declared variable, this data type is varchar. This data type is varchar. So now this is varchar and this is the data. Now tell me guys here. So your column data type and your column variable data type both are matching or not matching? Come on guys. Both are matching or not matching? Come on, guys. Both are matching or not matching? Both are not matching. So when both are not matching, then compulsory compilation error is occurring. In my program, compulsory compilation error is occurring. Your program is successfully compiled or not compiled? Yes, definitely your error, compilation error, data types are not matching, that error is occurred. Okay, now, so this is the problem we are going to be facing. This is the problem we are going to be facing, right? So now when we are using directly data type, so this kind of problems may be occur, okay, in my future. If in my future, suppose my table column data types are changing, then those columns, variables, wherever you declared in the program will be affected. The program will be affected. So the kind of problems that we are facing. Okay, now. But now, for example, in place of data types, if I'm using variable attributes, otherwise anchor notations, if I'm using, what is the advantage of user and what is the advantage of program means? Let you see. For example, at the time of variable declaration, in place of data type, okay, I'm using anchor notations. I'm using so anchor notation 1. Okay, now same to same in place of data type, second column, anchor notation 2. So in place of data type, I'm using anchor notations, otherwise variable attributes are used. So whenever you want to declaring, whenever we are declaring a variable with the anchor notations, okay, anchor notations, what happened? For each anchor notation purpose, internally your system is allocating some memory. So anchor notation 1, now anchor notation 2. For whenever you want to declare your variable along with the anchor notation, so memories are allocated. Memories are allocated. Okay, now memories are allocated. Then what it was happened in this memory, whatever the variable are you declared, this variable are you declared for which column? E-name column, right? This E-name column, which data type is having in this table structure varchar 2. So this varchar 2 automatically storing under anchor notation memory. So now it was storing like this. That variable are you declared for which column? That column data type, what it is in your table, that data type automatically stored in this anchor notation memory. Same like this, second variable salary. Salary variable I'm declaring for which column? Salary column. Salary column data type, what it is there? Number of 7, 2. Number of 7, 2. Then this number of 7, 2 storing under anchor notation number 2 memory like this. Number of 7, 2. So that means whatever the data type we are declared, or sorry, we are assigned for your column at the time of table creation, that data type automatically stored in your anchor notations memory. So now it was happening like this. Okay, for example, in the future, suppose user want to change. Now he was changing e-name column data type varchar 2 to, he was changing now date type. So whatever the changes are occurred in my table structure and table columns, automatically which data type you modified here, So same to same, that data type is automatically replacing to your anchor notation memory. Now in place of varchar 2, now what it was there guys here? Come on, what it was there here? Date. In place of this, what it was there? Date. Okay now, so it was replacing. Suppose in the future again, date 2, again I'm changing some number. Date 2, I'm changing some number. Again, this number is automatically changing in your anchor notation memory in place of date. In place of date. Now, what it was going to take care? In place of date, what it was taking? Number. What it was taking? Number. So, number is taking. So, that means what you understand, guys, here, whenever user will change a column data type in your table, the same data type automatically changing and updating into your anchor notation memory to that related variable. So in that cases, what happened? My program will not affected. In future, if you want to change that e-name column data type or number column, salary column data type, if you change, but that effect will not go to my program. Why? Because whatever you changed here, that automatically your declaration of variables also change. The declaration of variables also, variable data type also changed in your anchor notation memory. So that's why your program will not affect it. So this is the advantage of your anchor notations. So the same point I was given guys here. What I given, what is the advantage of variable? Okay, so variable attributes are whenever we want to change, careful observe, a particular column data type in a table, then the corresponding column variable data type also changed in variable attribute memory automatically. Come on guys, this point all of you clear now? So that explanation and this point clear now? So that explanation and this point is clear all of you? Come on guys. Okay, yeah. So this is the advantage of anchor notations. This is the advantage of anchor notations. Okay, now, right. But in our PLSQL, how many types of anchor notations means there are two types of anchor notations or variable attributes. One is column level, one is row level. Okay, what is column level? Column level is nothing but in this level, we are defining variables attributes for individual columns. Individual columns. So that means how many variables are you declaring for storing columns purpose, storing columns values purpose? Okay, how many variables are you declaring for your columns values storing purpose? That each and every individual variable wise, my attribute is created. My attribute is created. Okay now. So, and this column level attribute represented percentile type. Percentile type is a column level attribute representator. So, what is a representator of your column level attribute means percentile type. So, the syntax careful observe. What is the syntax? Variable name, table name dot column name percentile type. So this variable are you declaring for which column? The column name, and this column is belongs to which table? Table name also we are using. So for example, below I was given v underscore name is a variable. This variable I'm declaring for which column? ename column purpose. And ename column belongs to which table? emp table. Understanding now? So this is syntax of column level attribute. Now let you come out how to use observe. This is actually my program, right? But in this program, I was declared here two variables, but two variables I'm declaring with the data types. Okay, now. But now what I'm going to do, observe. So declared v underscore ename attributes I'm declaring. It's called anchor notation. What is anchor notation? Column level. So emp dot ename percentile type. V is a representative. Okay. Second variable salary. So emp dot column salary percentile type. Okay. So now what I did here, in place of data types, I am applying here anchor notations. Simple. I'm applied here anchor notations in place of data types. The remaining thing is same. Everything is same. Remaining code as it is. Declaration now, remaining as it is, I copied and executed. Nothing problem. 7788. Yes, you got it. Yes, you got it. Then what happened here? In this anchor notation memory, which column I said? ename column. Ename column, which data type is there? Varchar. So automatically in this memory, in this attribute memory, which data type is there? Varchar 2 of 10 data type is there. In this memory, which data type is there? Salary column. Salary column, which data type in your table? Number of 7, 2. So number of 7, 2 was there. Understanding my point now? Yes. So this is what individual columns wise we are declaring attributes. Okay, right. So this is column level attribute we call. Second one is called as a row level attribute. So row level attribute. What is row level attribute means? Okay, what is row level attribute means? In this row level attribute, we are declaring only single variable for different data types of columns. For example, like you see in my table, suppose in my table, total how many number of columns are there guys here? Eight columns are there, right? 8 columns are there. So suppose if 8 columns values, if I want to print means, if I go column level attributes, then how many variables I want to declare? If column level, how many variables I want to declare? Yes, 8 variables I want to declare. So each and every column individually, I want to declare 8 variables. But tell me guys, is it necessary to declare 8 variables? No need. So now tell me, instead of 8 variables, can I go for 1 variable is better now? Yes. Now what I'm going to do in row level attribute, that only telling. In row level attribute, what it was telling us, instead of individual variables, I want to declare 1 variable for all columns data types. That's why it is called a row level. Row. A row is nothing but collection of columns. Can I say? A row is nothing but group of columns. Can I say? Yes, we can say now, definitely. So that's why row level attribute advantage is what now? Instead of declaring individual columns, declare a single variable and that will represent all different data types of columns in a table. And what is a representator? Percentile row type. So now syntax, one variable name, table name, percentile row type. So which table? So the table name, percentile row type. Okay, now let me see one small program on this. So what is the program on this here? Same as usual. I need to declare here one variable. So I'm going to declaring here. Declare I. So EMP table name percentile row type. So one attribute anchor notation we declared. In this anchor notation memory, all columns or data types are stored. Okay. Later simply begin. After that, I want to take here ename. Suppose if I want to enter, suppose which you want it, EMP number, ename and salary. So that I want to store into I dot EMP number, comma, I dot ename, comma, I dot salary. EMP table. So where EMP number is equals to % of EMP number. Okay. Then DBMS underscore output dot put underscore line of now what is our variable here? I dot EMP number concatenating, comma, concatenating, I dot ename concatenating, comma, concatenating, I dot salary, and finally end and close. So now some number. Now you can see your required columns data. You got it. 7788 Scott and 3000. Suppose here what happens? Specific columns I selected here. 3 columns I selected. Suppose you need to select all columns. Then what we want to do, guys, here, in place of selected columns, I can use simply star into I from EMP, where EMP number is equals to % of EMP number. Okay. Now let it come out. So now same as it is. If I want to take this one, okay, as it is, how many columns you wanted, that for which based on that column you can pass one by one and to execute. Now let you see that the output is coming. But here the chance is there, what no star is there, so that you can pass like this each and every column. I dot EMP number, I dot name, I dot salary, I dot job, I dot department number, I dot commission. That all you can pass it because we are using what now? Star. Okay, na? So these are what now? Anchor notations advantage. Okay, na? So anchor notations. Okay, na? So is it mandatory? Mandatory, sir, means not a mandatory. You can use data types also at the time of variable declaration. But what advantage means, suppose in the future, if you want to change any column data type and that column related variable is there in the programs, so at the time affected. At the time your program will affected. So that kind of problem in future, if you don't want to get, there we can use an anchor notations. Otherwise, not a necessary. But in this example, only can you identify only declaration section only we are changing, remaining body as it is, right? Okay. So these are what we called as, guys, here anchor notations, and this is completion of your introduction part of PLSQL. So what it is as of now we discussed. Okay, right. And the next one is we already in your futures we discussed PLSQL language. Okay, supporting is one of the future in this. What is the future means? Supporting conditional and control statements, like it is saying that supporting conditional and looping statements, right? So now let me see what kind of condition and what kind of looping statements are supported in our PLSQL. So just observe the syntaxes. Let me check out that. And now we can see, and these things also same as, for example, already you have some little bit idea on C language, C++, Java, .NET, Python. So these syntaxes can easily understand. But little bit specification, syntactical specification wise, a little bit variations are there. but internal working nature, everything will be same. Okay. Yeah. Let you see. I just explained the syntactical specifications I'm explaining here. So carefully observe. So control statements. Okay. Let you see. Basically, control structures are statements. Okay. Let you observe, guys, here. Let you observe. So control structures, generally these structures we are using to control flow of the program. So whatever the logic we written in the program, if I want to check that logic, compare that logic, compulsory we need some conditions we need to write, and we need to write some logics. For that logic purpose, we need some statements like if-else conditions, nested if-else, multiple if-else, while loop, for loop. This kind of things are very required for us. So when we are using those statements, either looping statements or conditional statements, how your logic will be working, how your logic will be checking, how your logic will be executing, that flow is telling by control structures or statements, control structures and statements, right? Okay. So 1 second, guys, 1 second. Okay, right, observe. So the flow, that means whatever the logic we written in our program, that logic, how it was executed, the logic, how it was executed, that flow was telling by your control structures. And basically in our PLSQL, there are 3 types of control structures are there. One is conditional control structures, branching control structure, and iterations or looping control structures. Iteration or looping control structures we call it. So these are 3 guys here. First of all, check out here conditional control structures. So in conditional control structure, first one is called as a simple if. First one is called as a simple if. So simple if it contains only 2 block, guys. It contains only 2 block. That means in the simple if there is no false block. There is no false block. It contains only 2 block. And the syntax will be like this. If condition is true, then executing statement of 2 block and end. So if condition is true, then 2 block statements, whatever we written, so those statements are executed. But suppose your condition is false. Suppose your condition is false, then it never or it doesn't return any value. So why, sir, it is not written any value means there is no false block. There is no false block. So simple if what it was having here, only 2 block, and the 2 block statements when it was executed means when your condition is true. When your condition is true, then 2 block statements are executed. When condition is false, nothing will be written. Nothing will be written. Okay, now that is called a simple if. Next one is second one is called as the if else. If else we know. Suppose in if else, okay, suppose you need to display false block also I want to display, sir. Sir, I want to display true block, and whenever my condition is false block also I want to display, sir. So when you want it to true block and false block, if you want to display as per your condition, so there we can use a if else condition we are using. So it is called a if else. So if else, we all of you know syntax observe. So if condition is true, then true block statements are executed. Suppose if condition is false, then false block statements are executed. So here we have a chance to represent or to display false block information also. Okay, now because we have a two. Okay, so if else condition as well as a else part as well as a true block and else part, both are we having here. Both are we having here. Okay, that is what we called as a if else. Next one is called as a nested if. Next one is called as what now? Nested if. So nested if, what it was telling guys. Nested if, what it was telling guys. Means here, the nested if is telling us, the nested if is telling us, okay, now observe. If within the if is called as a nested if within the if is called as a nested if. The syntax carefully if you want to identify once. So once check out your, carefully want to check your syntax guys. Okay, now right. And now here observe. In this nested if condition, what happened? Suppose outer if condition is true, outer if condition is true, then enter into internal if condition. Then internal if condition is true, then execute a true block statement. Okay, what I'm saying, outer if condition is true, then executed internal if condition also. Internal if condition is true, then executed true block statements. For example, internal if condition is false, then executed else, that means false block execution. False block statements are executed. Okay, so this is one if else under if. Suppose your outer if condition is false. Outer if condition is false, then immediately it was jump to else part. Because my outer if condition is false. If outer if condition is false, then it was jump to else part. In else part, internal if condition is true. In else part, internal if condition is true, then executed true block statements. In else part, internal if condition is false, then executed false block statements. And finally, end your if. End your if else. So this is syntax of your nested if. Later we have a if else ladder. Okay, then we call a multiple if else also we can say. If else ladder, how it was means, the syntax is multiple conditions are checking one by one. So first condition, if condition is true, then executed true statements. If this condition is false, then it was come to second case is checking, second condition is checking. Suppose this is true, then executing. If this is also false, next condition checking. So like this, one by one condition will be checked. So that is called if else ladder. One by one, okay, step by step conditions are checking. So wherever the condition true, the statement will be print. Otherwise, it will go to next condition. Okay. So this is, and finally else and else part and end if. So these are the four things, guys. If else ladder 1, nested if else, nested if 2, if else 3, and simple if else, simple if 4. So total condition control structures are how many guys here? 4. These are the 4 types of conditional statements supported in our PLSQL language. Understanding now? Okay, right. Next come to branching statement. So branching statement, just like a switch case. In your front end side, we have a switch cases. Switch case statement, we have it. So your branch also like this. Your case statement in branching is also like that. So case, and you can send your variable or condition expression. Later, as for this variable or condition expression, we'll checking internally. So when your condition variable is true, then true. Okay, so the condition variable is true, then executed your statements, whatever you written. If conditional variable value is not true, then it will go to next conditional variable checking. If next conditional variable is true, executing statement, otherwise next will go. So like this, one by one, it will going to checking your conditions and condition variable values. Okay, so your constant means variable values means don't confuse constant, otherwise condition. Okay, now so actually here I want to give a constant. Okay, actually I have to give a condition, but I'm passing that constant or whatever, both are same. Okay, so better to take condition, otherwise you people are confusing. Okay, again you are asking what is constant. Okay, right. So this is, you can give conditions. So like the conditions you can give it now, variable conditions, whatever it was there, that conditions you can pass there. Okay, now, right. This is just a switch case how we are using in the front end languages, same like this here. Okay, now, right. Come to next one, iteration control statement. Otherwise, we can say looping statements also we can say. Okay, but here in PLSQL, for example, in front end side languages, some languages are supported like for each loop, do while loop, yes or no? So this kind of some additional loops also supported. But in our PLSQL, only 3 looping statements only supported, guys. One is simple loop, one is while loop, and one is for loop. So do while, for each, these kind of loopings are not supported here. Okay, so that was observed. So here simple loop. First one is simple loop. Simple loop, simply we call as it is an infinity loop, guys. It is an infinity loop. So why, sir, it is called as it is an infinity loop means, okay, the reason is what now? In this simple loop syntax or in this simple loop, for example, you written some logic. Okay, now, then that logic will be executing how many times means infinity times. That means there is no stoppable. Infinity means what now? There is no limiter and there is no stoppable. It always a continuous process. So that's why in this loop statement, problem is what now? Once you written some logic under simple loop, that logic will be executing infinity times it will execute. That means once you write logic and enter in your system, then your system is going to be running. So there is no stoppable. Yes or no? So infinity, if you just leave like this, so 24 hours it will be, your condition will be looping. Okay, there is no stoppable. So the kind of nature is a simple loop. But if I want to use the simple loop, then my condition will be that many times executed. So this is not necessary to execute that many times, right? So that's what the people will do as per your logic. Okay, then they want to break a simple loop, but then we are using exit statement. So in the logic only, in simple loop logic only, we are using exit statement. So what it was happen, certain up to certain limit of values are printed as per your given condition, then automatically your infinity loop will be break. It will be break it your loop. So compulsory exit statement we need to use. And how to do, I will show you programs, no worry. Okay, now in this syntax, now simple syntax, loop, execute statement and loop, that's it. So there is nothing was there in this. Just loop, execute statement and loop. So in this, whatever the logic you write, that logic should be exit. Otherwise, now it is infinity times your logic will be executed. Okay, that is what. And second one is called as a while loop, guys. So while loop, you know this, until the condition is true, your loop is executing. So same syntax, the while condition, and if condition true, enter into loop and executing your statements. And if you need increment or decrement, and finally end. Okay, na? So this is generally in front end also same like this. Okay, we are going to use it. So what it was, while loop, while and condition. If condition is true, enter into your loop and the loop statements are executed. As per your program, either increment or decrement, any one statement we can give and finally end it. Okay, na? Right. Come to next one is called as a for loop. So for loop, okay, by nature of for loop, by default, it is incremented by 1. Automatically, your I value or I variable values are automatically incremented 1 by 1. So that means user no need to write any increment statement. Okay, user no need to write any increment statement. Directly, automatically 1 by 1, it will be incremented. So now the syntax is observed. Syntax is what now for some variable, indexed variable or variable in starting value dot dot. Here 2 dots only can use. More than 2 dots don't use. So it is not a and so on. It is just a dot 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 end value. For example, suppose you need to print. Suppose you need to print 1 to 100 numbers you want to print. For example, 1 to 100 natural numbers you need to print. So whenever you want to print 1 to 100 natural number, so what is the starting value, guys, here? What is my starting value? 1. So starting value 1, dot, dot. How many dots? 2 dots. And what is your ending value, guys? 100. 100 is ending value. So once your loop execution reaching 100 or 100th number, automatically it will be break. Automatically it will be break. Okay, na? Right. So now, but here how it was, suppose I starting value 1, increment by 1 na, so 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4, 4 plus 1, 5, 5 plus 1, 6, 6 plus 1, 7. So like this, 99 plus 1, 100. 100 plus 1, 101. 101 is there. So 101 is exceeded, yes or no? It was exceeded for our loop condition. My nth value 100, but your loop is exceeded. When you exceeded 101, immediately loop will be break. Your loop will be break. Automatically your loop will be break. Okay, now. So that is starting and ending value. It will be like this. And later, as usual, whatever the condition you written or statements you written, the statements are executed. Okay, now. So these are what we can say, guys, here. Control and control structures. Okay, we can call as. Okay, now. So these all syntaxes I'm using in my topics wise, one by one program I'm writing now. In those programs, we are using this all one by one syntaxes. Okay, so when you go for an example, how I'm using these, what we can say statements, these conditional, control, okay, branching, how these statements I'm using in my programs, then you can understand it. So every day we are doing some programs. So concepts wise, so we are doing programs and the related which statement is suitable for our logic. So the statements we are using in program. Okay, to write your the conditions, yes or no. So slowly, when you see the programs one by one, automatically you can understand how it was working. Okay, na? So that's why before we started your programs, first we need to know the syntaxes. Once you just recalling syntaxes, then those syntaxes when I'm using in my programs, okay, when coming to concepts wise or topics wise, so you can easily get it how it was working. Okay, at the time again I will explain. I'm writing some logic by using of this, and based on that logic, we will go to explain to you how it was working. Okay, now. So this is what now control or else constructor statements or control statements or conditional statements we can call this. Okay, now. Right. So these are simply we called as a whatever the conditional, branching, and iterations which is supported under PLSQL. Okay, right. And the next one up to here, some introductions are completed here. So, and tomorrow I will start the main topic. Okay, that means main topics we entered like cursors, okay, stored procedures, functions, so whatever the PLSQL related topics are there. So that all one by one we can see it. Okay, all right. Okay, so right guys, thank you so much.